Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, we are live today. Okay, in this video, I would like to explain or share with you how to analyze frame. Okay, frame, indeterminate frame using flexibility method. Okay, are you ready? Okay, we will start right now, inshallah. Okay, so basically, flexibility method, as I have told you previously in other videos, is actually one of the method to analyze indeterminate structures. Okay, we can use flexibility method to analyze beam, frames, trusses, okay, composite structures, as well as, of course, any type of structures. Whenever we use flexibility method, whenever we cannot determine the reaction directly using equilibrium equation. Okay, that is where we have to use another method that is called as flexibility method. Okay, it is actually we use another equation. Okay, because equilibrium equation is not enough to calculate total unknown reaction in the system. So that is why we need to use okay, another equation. Okay, so basically I have actually explained to you how we analyze beam. Okay, now actually we are going to analyze frame, and beam as well as frame has similar analysis. Beam and frame has similar analysis because in beam we actually consider what we call as bending effect. Okay, bending effect. Okay, it relate with EI. Okay, EI or flexural rigidity. Okay, bending effect, EI referring to flexural rigidity in the system. Okay, this is for beam. Okay, for frame actually has similar analysis, means that everything here, okay, must be considered as well, plus it may have additional axial rigidity. But in many frame cases, okay, we just found that it has the same analysis because the effect of EA in frame, okay, can be neglected. So actually we can use the same analysis for beam and frame. Okay, even though frame if actually EI as well as EA. Okay, what is EA? EA is actually axial rigidity. EI is actually flexural rigidity. Okay, axial rigidity as well as flexural rigidity, and the dominant factor, the dominant effect in the truss, in the frame is actually come from flexural. Okay, this is dominant. So axial rigidity for this one can be neglected. Okay, sometimes when we calculate or we analyze frame, okay, we have to be able to identify when is actually we need to neglect the EI effect. Okay, basically number one, whenever there is no information about about the cross-section area in the question. Okay, when we need to consider, when we don't need to consider EA. Okay, whenever the information about EA or A. E, of course, will be given because in flexural rigidity also we have E. Okay, so EA or A is not given lah. Okay, is not given. Number 2, when we do not need to consider this axial rigidity in the system. Okay, when the info is not given, number 1. Whenever there is a statement in the question mentioning like this. Okay, consider bending effect only. Okay, consider bending effect only. Okay, whenever, okay, in the question you find that, okay, there is one statement mentioning about bending effect. Okay, basically like this, consider bending effect only, then you need to consider EI only. You don't need to consider EA. You don't need to consider axial rigidity because and EA can be neglected. Okay, number 3, when we don't need to consider EA, whenever there is a statement in the question saying that, okay, that we need to consider the primary mode of deformation. Consider the primary mode of deformation. Okay, in this case, okay, we need to consider only EI. In this case, we need to consider only EI in analysis. Okay, in analysis. Because whenever we need to consider both, whenever we need to consider both, okay, we categorize it as composite structure. Okay, we categorize as composite structure. So in conclusion, whenever we want to analyze frame, okay, and we understand that we need to consider the bending effect only, because whenever we need to consider EA plus EI, okay, in the question it will be mentioning about the composite structure. Means that we need to consider both effect, EI as well as EA, axial rigidity plus flexural rigidity. This is about the concept. Okay, so in conclusion, another conclusion, we will analyze frame. Okay, we will analyze frame just like we analyze beam. Okay, we will analyze frame just like we analyze beam. So what we analyze in beam? What do we do whenever we want to analyze beam using flexibility method? Okay, flexibility method. Okay. Okay, flexibility method. In flexibility method in frame. Okay, it is actually same thing. We still need to identify number 1 DOI. This is number 1. Number 2, why we need to calculate DOI? Because we want to identify redundant. Because redundant is depend on the DOI. Because redundant, okay, we identify redundant. Okay, second step, we identify redundant. Identify redundant. Okay, why we need to, okay, we need to always look at like this. Okay, look at this procedure like this. Okay, step number 2, we do step number 2 because of number 1. Okay, we do step number 1. Sorry. We do step number 1 because of number 2. We do step number 3 because of number 2. Okay, it actually relate with each other. Okay, DOI. Why we need to calculate DOI? Because we need to identify redundant. Why we need to calculate DOI? Why we need to calculate DOI? Because the answer is number 2. Okay, the answer is number 2. Why we need to calculate DOI? Because we need to identify redundant. Because we know that number of degree of indeterminacy is equivalent to number of redundant in the system. Okay. How to identify redundant? How to identify redundant? We identify redundant, okay, because we need to have the knowledge about redundant, because redundant is to remove from the system. This redundant is to remove. This one is to remove. Okay, this one is to remove. We need to remove redundant. We choose redundant because we need to remove redundant. Okay, and the idea of removing redundant in the system, okay, from the system, is to get statically and determinate condition. And the system after removing redundant is called as primary structure, or in frame it is primary frame. So how we get primary frame? It is actually we fulfill the principle of superposition. So we have the equation. Okay, we have the equation. It is equal to the equation is general equation. We have the general equation. Okay, we have the general equation which is based on the principle of superposition. Okay, so identify redundant, we write the standard form. Okay, okay, we don't need to rewrite what is the standard general equation, because okay, from general equation we are actually writing or forming or deriving, okay, what we call as compatibility equation. Okay, writing write standard form of compatibility equation. So this is the step. Write standard form of compatibility equation is the step. Okay, number 4. Okay, okay, we identify. Okay, please always see like this. Okay, please always see like this. Okay, the answer for 1 is 2. The answer for 2 is 3, because we want compatibility equation, because when we solve compatibility equation, we get the redundant value. Okay, when we solve compatibility equation, we get the redundant value. Again, we want to identify redundant. We remove redundant. Okay, and the structure after removing redundant is called as primary structure. And in fulfilling the principle of superposition, we have another structure called redundant structure. And primary structure as well as redundant structure, okay, actually fulfill the principle of superposition. Okay, and from principle of superposition, we actually deriving, okay, the equation that is called as compatibility equation. Okay, why we need to have compatibility equation? Because when we solve compatibility equation, we get the redundant. So what is actually compatibility equation? Okay, what is inside compatibility equation? Okay, we need in compatibility equation we need to calculate displacement. Okay, so incompatibility equation, incompatibility, standard form of compatibility equation, incompatibility equation. Okay, incompatibility equation, we need to calculate displacement. Displacement in primary system, primary frame and redundant frame. In primary frame and redundant frame. Okay, in primary frame and in redundant frame. In primary frame and in redundant frame. Okay, and after that, number 5, we solve for the redundant value. We solve for redundant value and then we will calculate the remaining reaction. Okay, calculate displacement and then calculate redundant. Okay, calculate redundant, calculate or solve redundant, and then 6. Okay, we need to solve remaining. Okay, solve remaining reaction, remaining reaction. Okay, three remaining reaction, 3 reaction. Okay, this remaining reaction actually can be solved either using equilibrium equation or principle of superposition. Okay, principle of superposition. Okay, so maybe we need to consider one example here. Simple example is enough. So let's say we have frame like this. Okay. One or two redundant, one redundant. Okay, one redundant. It is like this. This is moment. Okay, this is 2000 Newton meter. Okay, this one is 750 Newton per meter. This is 10 meter and 10 meter. So this is A, B and C. Okay, so step number 1, we need to identify one, degree of indeterminacy. So in this case, there are 4, so it is 4 minus 3 is equivalent to 1. And then after that, we will choose redundant. So this is one redundant, so I put as R1. Okay, I want to choose moment at A, so it is MA. Remember that moment as redundant, so it is M theta. Okay, so we will get theta A naught, okay, plus FAA MA is equal to 0. Or we can also write as theta, because the label is 1 here, so we can put 1 naught plus F11 times R1, or we can also put MA. Okay, I prefer writing equation like this. Okay, so this is the equation. So from this we know that there are two displacement. Okay, so theta 1 naught is actually 1 over EI from 0 to L, M1 M naught dx, and F11 is actually 1 over EI from 0 to L. From 0 to L, it is M1 square dx. So we will have two frame. One is called as primary frame. Another one is called as redundant frame. Redundant frame. redundant frame. Primary frame and redundant frame. So in both frame has the same characteristic, means that A will become pin after removing MA. So we have like this. Okay, we have like this. It is 0. Okay, and the column. Okay. Okay, so 10 meter, 10 meter, 2,750. Okay, 2,750. So here we put 2,750. Okay, and redundant frame, we have a unit value of moment at A. So we put here 1. Okay, so it has pin here, roller, pin and roller. Okay, why we need to do this? Because we want the reaction. And why we need to have reaction? Because we want to write moment equation. Okay, we want to have moment equation. Okay, and moment equation needs reaction. Okay, moment equation needs reaction. Why we need to have the moment equation? Because in the formula of displacement, we must have the moment equation. Okay, so we write the moment equation because of, we want moment equation because we want to calculate displacement. We want to write the moment equation because we want to calculate reaction because of the moment equation. Okay, start with reaction. Reaction give us moment equation. Moment equation give us displacement. Reaction give us moment equation. Moment equation give us displacement. Okay, so we calculate the reaction. Actually, reaction does not need to show. Okay, you can actually determine or calculate the reaction, okay, outside this and put the value only. Because what I want to know is only the value. Okay, it's only the value, not the step. Jadi 10 meter, 10 meter, 10 meter, 10 meter. Okay, I will calculate here. Okay, for the moment equation, for the reaction by taking moment at A is equal to 0. It is, because here is AY and AX, this is ABC. This is CY. Okay, it is 2,000 positive plus 750 times 10 times 5. Okay, CY, it is minus 10 CY. Minus 10 CY is equal to 0. So here we get, okay, we get 2,000 plus 750 times 10 times 5 divide by 10. CY is equal to 3950 kilo Newton. Okay, it is 3950. So this is equal to 3950 kilo Newton. Sorry, this is CY. This is CY, 3950 kilo Newton. So what is AY? AY is 750 times 10. Okay, minus 3950. It is 3550. 3550. So AX is equal to 0. Okay, so this is actually the reaction in the primary frame. Okay, we move to redundant frame. Redundant frame, so we will get, okay, we will get 1. Okay, 1 minus, because this is also AY, CY. Okay, this is AX. Okay, CY, 10 CY. 1, it is positive 1 times, okay, it is 1, not times. 1 minus 10 CY is equal to 0. So we get CY is equal to 0 0.1. It is 1 divided by 0 0.1 divided by 10, it is 0 0.1. So we put as, okay, it is 0 0.1 and AY should be negative 0 0.1. AX is equal to 0. Like this. So now we have this primary frame and redundant frame. Remember that we calculate reaction because we want to write the moment equation, and the moment equation will be depend on the reaction. Without reaction, we cannot write the moment equation. Okay, without reaction, we cannot write the moment equation except certain case. Okay, basically we write moment equation from reaction. Okay, once we have reaction, then only we can calculate, we can write the moment equation. Okay, this is all the reaction. So by looking at these two diagram, so we have two cutting section. Remember that for these two diagram, it must have standard. It must have the same cutting section. Okay, the same cutting section. So here we have two cutting section, AB as well as BC. This is ABC. This is ABC. Okay. So when we want to write moment equation, remember that we need to consider sign convention. And sign convention for moment equation that we choose to use or choose to refer is actually positive sign convention. So for positive sign convention, it is actually, okay, depend on the origin. Depend on the origin. For example, if for AB we want origin start from A, okay, we will get counterclockwise for both. Okay, yeah, this is when A as origin. When B is origin, the moment is counter back. Okay, if this is the counterclockwise, okay, the other one is clockwise. Okay, because the concept of moment equation is when we combine back the section, okay, the section that we cut, it will get 0. Okay, when we combine back, because in for member AB, we can have either, okay, for AB, okay, for AB, for the moment equation, we can have A, okay, we can have this A, like this. This is A, or we can have this. And when we combine this back, when we combine the cutting section, okay, the column that we cut, when we combine, the moment is equal to 0. Okay, so when we choose A, okay, choose A, we have to use this. Okay, when you choose A as origin, this is the section. This is when A as origin. This is when A as origin. And this is when B as origin. This is when B as origin. Okay, same goes to BC. Same goes to BC. For BC, we also have choices. We also have choices. For example, BC, we have this and this. So B to C, the one that we cut, whenever we combine back, it will equal to 0 moment. It will equal to 0 moment. So if we choose B as origin, if B as origin, we will have this. Okay, I don't want green. Okay, maybe red. Okay, if we choose B as origin, this one is, okay, this is when B as origin. So this is B as origin. And when B as origin, the moment is counterclockwise. The moment is counterclockwise. Okay, what if we choose this one? Okay, so that one is for C as origin. Means that the moment equation, origin is very important. Origin is very, very important. The free body diagram will depend on origin. The limit of section of X, will also depend on origin. Okay, so for C as origin, the moment is clockwise because BC here, when we combine back the cutting section, the two cutting section, okay, we will get 0. So from this we can conclude that if, okay, by looking at the diagram, we can conclude like this. When we can have counterclockwise moment and when we have clockwise moment. Okay, just look at the diagram. Okay, A as origin, because we have frame like this. Okay, for the origin this member, so this we will get opposite. So where is left, where is right? This is left, this is right. Okay, left and right. Okay, left and right. So by looking at, okay, this one, A as origin is left. Okay, origin is left. And when origin is left, the moment is counterclockwise. Okay, and okay, so we move to BC. Okay, B can be origin, C can be origin, A cannot be origin because X always move in straight line. B can be origin, C can be origin. Okay, B and C, where is right, where is left? Okay, right at C, B is left. So that is why we can conclude as whenever, okay, when we put origin from left, okay, in summary, when we put origin from left, okay, moment is counterclockwise. Logic, right? Left counterclockwise. And when we put origin from right, moment is clockwise. Okay. It is like this. Okay, loop logic. Okay, left counterclockwise, right clockwise. Okay, so you just need to be careful about the sign convention, because when you put wrong sign convention, of course you will write the wrong moment equation, and it will give you the wrong reaction or redundant. Okay, so careful with the moment equation. Okay, so go back to the question. So whenever we want to write moment equation, make sure we choose the shortest section or the easiest, okay, the easiest way. For example, by looking at this diagram, for member AB, the easiest or the shortest section will be the origin must be A. And for BC, the shortest section is the shortest section is when we choose C as origin. Okay, this is X, 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 X. Okay, so for AB, we know that it is counterclockwise, and for BC, it is clockwise. Counterclockwise, clockwise. So we write the moment equation. Okay, we can write the moment equation and we put in the table form. Okay, we put in the table form because we have more than one section. So we better put the moment equation in table form. Okay, I believe that the problem now is the moment equation. I found that students normally have the problem in writing the right moment equation. So I think if you are clear with moment equation, I believe you can do this analysis until the end, because it is actually same with beam. Okay, because we just need the moment equation because of displacement. So once we have displacement, we can substitute into the compatibility equation, and then we can solve redundant, and from redundant we can solve the remaining reaction. And one problem is the moment equation. Okay, I believe this is the only problem, because whenever you clear about the moment equation, okay, I believe everyone can solve this until the end. Okay, I think that's all for this session. Okay, maybe I will continue to answer this, and I will share it to you in the Teams chat, the link for this the link for this solution, the until the end of analysis. Okay, inshallah, I hope this session will help you to understand more about the moment equation. Okay, till we meet again, inshallah, in the next video. Okay, assalamualaikum warahmatullahi wabarakatuh.